recording.
Let's go. All right, so on this review, here's what's going on. On my YouTube channel, Mr. Wyrick Math, it's always going to auto-correct a space between the Mr. and the Wyrick Math. Don't let it auto-correct that space because that's my channel. I don't know. Make it not autocorrect, take the space out, whatever you got to do. On this top part where it says identify the points of discontinuity, if it's a point of discontinuity, it makes 0 on the bottom. Okay? So anything that would make this 0. So on this first one, 0 makes 0, 16 minus 16 makes 0, and a negative 4 plus 4 makes 0. Those are the points of discontinuity. On this one, switch the sign, put it over that. 7/3 and negative 6 are my points of discontinuity. On the bottom part of this, same thing. You factor, then what makes it 0? This would be x plus 2 and x minus 4. So to make those 0, it would be negative 2 and positive 4. Okay? Good times all the way around there. On this where it says simplify, then state any restrictions. You start by factoring. This is x plus 5, x minus 4. Down here on the bottom, it's x plus 5, x plus 6. So the x plus 5 and x plus 5 match up. This is your simplified version. So if that's my simplified version, I still go back to the factored version for my points of discontinuity, which are negative 5 and negative 6. Now, on this part up here, where it says the points of discontinuity, if you need to do the points of discontinuity and you can't figure out how to factor and you have trouble with factoring and whatever, all you got to do is graph this and then Control T, pull up the table. You roll through that table, anything that says the little hashtag undefined, like that's your points of discontinuity. Check and see if it matches up to the answer. Okay? On this part with the simplification, they are equivalent. Anytime you're supposed to look for equivalency in a graph, it's going to be the graphs match up. So you can just graph the original, graph all of the answers, see if they're the same. On the add and subtract, again, it's equivalency. You can just graph it, graph the answers. It's going to take a long time, but you can graph it and graph the answers, see which graphs are the same. On one like this, I've got x plus 7 and x minus 6 on the bottom. This other side already has the x plus 7, so I'm going to multiply by x minus 6 over x minus 6. That gives me x squared plus 2x minus 35 on the top of the original one. Okay? I've still got that exact same thing on the top of the original. And then when I multiply this 3 by x minus 6, that's 3x minus 18. I put that both in parentheses and I am subtracting. So I'm just looking to combine like terms. The x squared won't change. 2x minus 3x will give me a minus x, and then a negative 35 minus a negative 18 is the same thing as negative 35 plus 18, which would give me a minus 17. Nothing's going to multiply to make negative 17 and add to make negative 1. So that's as far as that's going to go. And I can either put this in factored form, x plus 7 and x minus 6, or I can put it back into the original form of x squared plus x minus 42. If you get to where you can reduce them to make it to where they have the same denominator, you can do that, but only if it's going to make the same denominator. If you have to reduce it and then end up in multiplying by the same thing, it's not going to help anything. I could have, if this was an x plus 7 on the top, which it is, taken that x plus 7 out, but it would have given me x minus 6 and x plus 7, not the same denominator, so I'd have to multiply it back in anyway. Waste of time. Okay? See if it makes sense to do it, then do it, or graph, graph, and graph. Okay? It's multiple choice math. The graph can be your biggest friend. Multiplying and dividing, same kind of thing, but you're looking for the most reduced it can possibly be. So you start by factoring. This is x minus 8, x plus 3 over 2x times x plus 3. So already, top and bottom, I've got factors that match up. Then I'm multiplying by 5x squared over 8 minus x. This one's tricky because it's essentially the same. If we write it in backwards order, that's negative x plus 8. So I can factor a -1 out of that and make it x minus 8. Okay, same thing. I'm just rewriting it in a way that suits me because then x minus 8, x minus 8. X squared on the top becomes a single x and this x goes away, but 5 is not divisible by 2. So what I've got left is a 5x on the top because the others have been eliminated. And on the bottom, I've got a 2 and a -1. So it's a -5x over 2. Okay? It reduces a long way. Again, graphing these will yield the same results. It will give you this. If you graph it, those will show up as the same graph. Except you'll have your points of discontinuity in the original that aren't there in this one. Okay? Remember, if it's dividing, it's the whole keep, change, flip. So this would be, 19 and 84 is going to be, it's not 14 and 5, 12 and 7. So t plus 12, t plus 7. And that's over 4 times t minus 1. Okay, then I'm going to multiply, I'm going to flip this. 2 times t minus 1. And then this would be t plus 7, t plus 2. So the ones that match up, the plus 7, the plus 7, the minus 1, the minus 1. And then t plus 12 over t plus 2. This 2 goes down to a 1, and this 4 goes to a 2, because reducing fractions, that's t plus 12 over 2 times t plus 2. This is just how these work, okay? Now, down here on the bottom, just want to mention, this, when you get these fractions like this on 23, this central fraction line really just means you are dividing. Keep the first one the same, change that sign to multiplication, and flip that last one, and you'll have it. Okay? It's just a different way of looking at it. On this back page, when it says solve, here's the most beautiful thing about anything that says solve. You're going to have number answers. So if you get stuck on this on the test, take the number answers that they give you and put them in place of x and see if it works. If they give you a 5 as a possible answer here on number 1, that's 5 minus 2 is 3, 5 plus 4 is 9, that's 3 over 9, which is 1/3. But then up here, that'd be 5 plus 1 is 6, 5 plus 10 is 15, that's 6 over 15, which is 2/5. Not the same as 1/3, it's not the answer. You could also just type those in with the 5 in the place of the x on the calculator, and when you have the equal sign, it will tell you if it's true or not in the calculator. Just flat out tell you. If you want to do these, of course, you cross multiply. That's x plus 4 times x plus 1, which is x squared plus 5x plus 4. And that's equal to x minus 2 times x plus 10. That's x squared plus 8x minus 20. My x squareds are the same on both sides. So I just work to where I'm going to have the larger x. Minus 5x, that's 3x. I add 20, that's 24. So 24 is equal to 3x, x is 8. Okay? When you have one like this, you add these together first. So go back to what you were doing on adding, and then you'll cross multiply. If you have something like this, though, you can take this one and move it over here. So you'd have 7 over a plus 3 over 4a. That's a little bit easier to make it to where you have a common denominator. That'd be 28 over 4a plus 3 over 4a, which is 31 over 4a. Okay, sorry, that's a terrible looking a. And that's equal to a 5 over 1. If you have a whole number, it's over 1. Cross multiply, and you get 20a equals 31. A is equal to 31 over 20. Okay, you can work through these pretty easily to get your answers. It's just a matter of knowing how to do it, going through it correctly. But If you want to get the answer on the test and you can't remember all the steps, you're not sure, then sit there and take those answers from the test, put it in and check it. Okay? There's a workaround for pretty much everything we've been doing. Not for the papers that we've been doing, which is why it takes a little longer to get them done. But the test being multiple choice means the answer is on there. So hopefully the video will help you out. You can study from that. There's also the video over solving. I do have after school tutorials today, but there's a last minute faculty meeting, so I'll be slightly late to them. Wait for me at my desk, I'll show up.